All right, this is 10.3 where we're talking about arcs and chords. This first section here is review of 10.1 and 10.2. I'm just going to walk you through how I found the radius of the circle. Okay, so remember with what we have here, the radius is a length. We have one arc length, arc Rn. Okay, so the arc length is 4. So the arc measure, or the central angle, is 20 degrees. Okay, so for this ratio that we're setting up here, we're using that ratio we learned in 10.2, which is arc length over circumference equals arc measure over 360, because the arc measure is out of 360 degrees. So the arc measure is 20, the arc length is 4, 20 is out of 360 degrees, and instead of circumference, I put 2 pi r. So that's another way to find circumference, and that way my only variable is r, which is radius. So I cross multiply, get this, divide by 40, then divide by pi to solve for r, and get that the radius is 11.5. All right, moving on to new stuff. Congruent arcs postulate. If two arcs are congruent, so if arc FG is congruent to arc HJ, then the chords creating the arcs, so connecting those same endpoints, are also congruent. So FG is congruent to JH. All right, so I want you to just pause here, and this first one just uses that theorem exactly. So pause here and try this on your own. All right, so if in the embroidery hoop, AB is congruent to CD, and the measure of arc AB is 60 degrees, find the measure of CD. Well, since the chords are congruent, the arcs are congruent. The measure of CD would be 60, or 60 degrees. Okay, next one. We'll do this together. In the figures, circle J is congruent to circle K. This matters, okay? So far with the congruent arcs postulate, we've been within the same exact circle. If we're in different circles, for this to work, the circles have to be congruent to each other so that they're the exact same size, so that measurements are staying exact or staying equivalent. So in the figures, the circles are congruent, and MN, arc MN, is congruent to arc PQ. Find PQ, so find this length here, the measurement of segment PQ. Well, if the arcs are congruent, then the chords are congruent. So that means 2x plus 1 equals 3x minus 7, and we solve. So 1 equals x minus 7, so 8 equals x. But we want to find PQ. PQ is 3x minus 7. X is 8, so it's 3 times 8 minus 7. So 24 minus 7, which is 17. So PQ equals 17. All right, some more theorems. Chord diameter theorem. If a chord, so here XY, is perpendicular, so it creates a 90-degree angle to the diameter, then the diameter bisects the chord, so XZ and ZY are congruent, and bisects the arc, so XB and BY are congruent. So arc XB equals arc BY, and segment XZ equals segment ZY, because the chord is diagonal, or not diagonal, is perpendicular to the diameter. So then inversely, if a chord is perpendicularly bisected, so if you have a chord, it's bisected and it's perpendicularly bisected, so its bisector is perpendicular to it, then that bisector is a diameter. All right. So using that theorem and converse that we just learned, try this first one on your own. All right, so we'll circle S. Measurement of PQR, arc PQR is 98. Find the measurement of PQ. Well, this chord is perpendicular to this radius, which is also a diameter, which means the chord is bisected and the arc is bisected. So if an arc of 98 is bisected, divide it by 2 to find one of its halves. So the measurement of PQ, which is a half of it, is 48 or 49 degrees. Next one, in the stained glass window, diameter GH, so this is a diameter, is 30 inches long. So I'm just going to mark that this radius is 15, since it's half the diameter. And chord KM is 22 inches long. So notice that GH is perpendicular to the chord, so that means the chord is bisected. So if KM is 22, then KL, I'm just going to label this one, is half, so 11. Find JL. So we want to find this, call it X. So notice that this dotted line is put in here from JK. Well, JK is a radius, so that also has length of 15. And look, we have a right triangle. Hypotenuse is 15, 11 is a leg, and we want to find this other leg. So what we can do is use the Pythagorean theorem to solve for x. So x squared plus 11 squared equals 15 squared. So x squared plus 121 equals 225. So x squared equals 104. So x equals the square root of 104. If I reduce this radical, 2 and 52, 52 can divide by 2, we get 26. 26 is 2 and 13. I have a pair of 2s, so I can pull out a 2. Whoa. So I can pull out a 2. And in the square root, I'm left with the 2 and the 13. 2 times 13 is 26. And then we could then, if you're asked to round to the nearest hundredth, actually put this in your calculator and you get 10.20. All right. On this next one, find the length of TV. All right, so notice, again, that we have a radius or a diameter intersecting a chord at 90 degrees. So it bisects this chord here. Okay, so TV is bisected. So TS equals SV. We want to find TV. So let's work on finding half of it. So it's going to kind of look like that last problem that we did. So let's find TS. We know that this is 6. So if I draw in this radius here from T to R for the hypotenuse of a right triangle, well, this radius here is 6 plus 5. So this is also 6 plus 5, which is 11. So the right triangle we're looking at, we have 6, 11, and an unknown. And remember that unknown is half of TV. So TV equals 2 times whatever we find. So x squared plus 6 squared equals 11 squared, using the Pythagorean theorem here. So x squared equals 85. So x equals the square root of 85. 85 divided by 5 is 17. Can't reduce the radical. Let's write it to the nearest hundredth, so 9.22. So x is 9.22. So TV equals 2 times 9.22, which is 18.44. And there's our answer. All right, one last definition, congruent chords theorem. Two chords are congruent if they are equidistant from the center. So, if we look at this image, two chords are congruent. So F, G, and G, H are congruent because these aren't marked in here, but it should be. So I'm just adding something that's missing. So we're told that XL is congruent to LY. Those are the distances from the chord is from the center L. So FG and JH would be congruent chords. Okay? And since the chords are congruent, then the arcs are congruent. So a lot happening there. All right, two more examples. In circle A, WX equals XY, which equals 22. Find AB. So we want to find this length here. All right, so those two chords are congruent. WX is congruent to XY. So if the chords are congruent, that means they're the same distance from the center, meaning AB is congruent to AC. So that means 5x equals 3x plus 4. So if I solve this for x, I get x equals 2. We want to find AB. AB is 5x, so it's 5 times 2, so AB equals 10. All right, last one. If QM equals 6x minus 11 and MR is 2x plus 9, find MN. All right, things I'm noticing. We are told that QP is congruent to PR. That means that LM and MN, these chords are congruent because they're the same distance from the center. So LM is congruent to MN. I also see that this radius is perpendicular to that chord, and this radius is perpendicular to this chord. So that means LQ is congruent to QM, and MR is congruent to RN. And I'm only using one hash for all of them because if LM is congruent to MN, then their halves are congruent. LQ is congruent to RN, which is congruent to MR, which is congruent to QM. So that means these two are congruent. So if I set those equal to each other and solve, I can find x is 5. So then MN, which is here, remember it's split in half, so 2x plus 9 is half of MN. So MN is 2 times 2x plus 9. So if I plug in 5 for x, like this, I can find the value or the length of MN. So 2 times, oops, I added an extra 1 here. So 10 plus 9 is 19, and 2 times 19 is 38. So MN would equal 38. And that completes the notes for 10.3.